Alright, here we go. Today you are going to learn about the geometric mean, how you find the geometric mean between two numbers. Not that difficult, really it isn't. And then you will also solve problems involving parts of a right triangle and its altitude to the hypotenuse. And that one, there's some interesting things to that, but we'll see what we can get to on that. The examples there, they're going to look difficult, but they do get easier as you go through it. So let's look at what is a geometric mean. Okay, so the geometric mean, what it really is, there's a long definition that the book gave, and I was like, no. Basically, all it is it's the square root of two numbers multiplied together. Okay, or the product of two numbers. So basically, you multiply two numbers, take the square root, and you've got the geometric mean. So, for example, if I wanted to find the geometric mean of, say, 9 and 4, okay, then I would just do 9 times 4, which is 36, and then take the square root of that. So take the square root of 36, and you would get 6. Now, what happens if you get a number that's not, say, wouldn't be the perfect square root, like 8 times 10, 8 and 10 would be 80, and then you take the square root of 80. Well, now I would want you to simplify that rather than just type it in the calculator and give me the decimal answer. So in this case, when you simplify that, that's 4 square root of 5. Now, if you don't remember how to simplify, or you want me to go back over that, feel free to ask in class, and I will be more than happy to go over that, all right? And we'll kind of go from there. So, next part. I do want to make note that 4 square root of 5 would be approximately 8.9 if you type that into the calculator. So, notice that the mean here is not an exact in-between average. Okay, so one more example here. 5 and 45. 5 and 45 is going to be 5 and 45 is 215. Take the square root of 215, you get 15. So there you can see the geometric mean. And why is this important? There's a proportionality that was discovered that has created this whole idea about geometric mean. And when you think about that's like that, there's that proportionality. It helps when we start looking at similar shapes. Alright, so here's a theorem, and this is where kind of get into the real meat of this, is that they're saying, let's talk about similarity. If the altitude is drawn to the hypotenuse, so if you basically draw from the right angle to the hypotenuse a line that would make a 90-degree angle, then the two triangles formed are similar to the original one and to each other. So in other words, there's a proportionality to all of these. Okay? So you can see how this is drawn. You can see the wording there. So let me give you an example. So here's a right triangle, FGH, or however you want to put it, and we're going to draw a line from the right angle to the hypotenuse that would form another right angle. So now we actually have 3 right triangles. We have a small one. This feels so much like Goldilocks and the Three Bears or something. I'm going to say that's point J. So we would have a small one that would be at J, G, F, because again that would be 90 degrees right there. Then we would have a medium one that would be J, 90 degrees. Notice where the 90 degrees is. HG or GJH, and then we would have the original large one, which would be FGH. So it's like I said, it's like Goldilocks and Three Bears. We have 3 triangles. Okay, so what happens here is that if you go and notice here, what I'm going to do, you have 3 triangles. Okay, FJG is similar to GJH, which is similar to FGH. So that means that like where you did all that cross multiplying, you would be able to do stuff like that here. Now, keep in mind, I may ask y'all to do some questions where we do the similarity statements. Make sure you can divide it up into 3 triangles. But due to time constraints, I'm going to move on to the next part. Okay, so this next part, you got these 2 theorems, and they're basically telling you how you can set up something. And basically what happens here is it's easier to kind of see the example, but what we're going to do is we're going to be using geometric mean to help us find other sides of the triangle when we only have maybe part of one side or two. Okay? So, for example, so in this example, I have a triangle. The large triangle is KLJ, and then I have smaller triangles like MJL and MLK or whatever, and I want to find X, Y, and Z. So I want to find, say, these little points right here, and how do I use a 20 and 5 to do that? Well, first off, always work on finding this one first. Find that altitude first, or if you already have the altitude, work from that one, because that one's the easiest one. If you're looking for the altitude, the one that like divides up the big triangle, then all you got to do is take the geometric mean. Oh, apparently I was telling you that. And according to theorem 8.2, if you take the geometric mean of 20 and 5, get 100, then you get the length of x. So in this case, the x is 10. Then for the other ones, now you got to pay attention to what they are adjacent to. Okay. In other words, for y, notice how y touches the 5. Okay. So you're going to take the geometric mean, but the way this one works is like this. We go 5 times what is 5 plus 20. So you need to be able to add up that hypotenuse there. So 5 plus 20 is 25. And then you could multiply that, get square root of 125, which is 5 square root of 5. Z touches the 20. Notice how it's part of the 20. So for Z, we're going to say 20. 20 times square root of 20 times 5 to get 500, which is 10 square root of 5. Okay, so you just got to pay attention to this, and it makes it a lot easier. Now let's look at another example, because I think this one is the one that needs more examples. All right, and actually I'm going to do 2 more examples. Okay, so notice here how I started this out. I've got X, Y, and Z. Now, again, what I always say would be the easiest thing to do, and I'll put here X, Y, and Z. I would start off with the one that's the altitude, in this case, Z. Okay, all you got to do for that one is say square root of 8 times 25, and you get square root of 200, which is 10 square root of 2. And again, if y'all don't understand it from going from here to here, just let me know and I will answer questions about that. Okay, now notice that X is touching which one? The 8 or the 25? X is touching the 8. So that means I'm going to start off with the 8 and say square root of 8 times 25 plus 8. Whereas the Y, and get 264, which is 2 square root of 66. The Y is 25, because it's touching the 25, times 25 plus 8. So notice here, we're always adding those two, the parts of the hypotenuse, or parts of the other legs, if you want to look at it that way, to get that next answer. And it's 825, so that one's 5 square root of 33. So you got to kind of remember that. Now, how can I make that a little bit more difficult? Because that once you start getting that idea, then this becomes easy. Well, let's do one more example here, and let's see how that gets a little bit more difficult. Here, I give you the altitude. So I give you that number that's across. So remember, what we normally would have done, if you come back here, we would have, for this one, said, multiplied these two bits to get this one right here. Well, what happens if I've already got this one? Now we start undoing things, just like you would in regular algebra. So here, we're going to say 12 is equal to x times 9. Well, how do you get rid of a square root? Well, you get rid of a square root by squaring. So when you square something, you get rid of the square root. So that would give me 144 is equal to 9x, which I can divide by 9 and get x 16. Now that works out nicely, because then from there, it's just like what we've done before. 16 is touching the y, so that's going to be 16 times 9 plus 16. The z is touching the 9, so that's 9 times 9 plus 16. And then you do the same steps over. Now, since I'm running short on time, I'll talk about the application of that more in class. But the idea here is this actually allows us to do some stuff that is pretty ingenious as far as like indirect measurement and civil engineering. So anyways, That is it for today. I thank you for your time. And for an extra credit bonus word, let's go with diving. Okay, make sure you share that to me on your notes, and then I will give you some extra credit on your next quiz. All right. Thank you so much for your time. Y'all take care and have a good day.